Welcome back. Today we're going to cover families. I'm just going to explain to you guys the three stages of building a Revit family, which consists of modeling, nesting, and also placement. So under modeling, essentially we have the geometry. Geometry consists of forms, voids. Forms consist of extrusions, swept blends, swept, and so on. And then also voids, they include swept blends, revolves, extrusions, sweeps, and so on. And also we have dimensions, obviously, and then we have reference planes, which play a major role in how you constrain your families. So these are very much sensitive because they can either distort or mess up your family. So you have to be careful on how you apply them. And then we have reference lines, which play a major role on setting up the work planes of where you want to place your profiles and also your forms. And then we have the parameters, which I believe are one of the most important aspects of creating a Revit family because they play a major role on how you constrain your family first and how versatile your family can be, and also uh, they make your family parametric basically. And then you have the nesting, which is a second stage. And nesting is basically combining two families together. So the basis of nesting families consists of a host family. A host family is uh, your main family, whereby you host different sets of families into one. And then you have the loaded family, where this is the family whereby you nest into the host family basically. And then the shared parameters, which I believe are the most important aspects of nesting families, because in terms of quantities, shared parameters, they make sure that two different sets of families are separated, especially when you create a schedule in a Revit project environment. So this is very much important, especially when you try to extract quantities, because Revit will detect your family as a single unit when you don't use shared parameters. You can have two different sets of families of two materials. Like for instance, the example I'm going to use right now, it's going to be a box girder, which is made up of concrete and with steel struts, which is made up of steel. If you don't use shared parameters for that, it's gonna detect it as a single unit, which is wrong. So in this instance, we're gonna use shared parameters so that we can separate the steel elements from the concrete elements. And then we have parameter association. This is whereby you associate the parameters of a geometry into the host family. So think of the host family as our box girder, and then the steel strut is going to be our loaded family. We're going to use parameter association to associate the parameters of our steel struts in our host family, so that we can control the parameters of our steel struts into our host family. All right. And then the last stage involves placement. So placement, it depends really on the type of template that you choose to create your families. So it can be either phase-based, adaptives, which are one of the most intelligent and versatile and flexible family templates that you can use in Revit. And then we have the arrays. Usually these are line-based families. There is a template for line-based families. And then you have 2 points or 3 points. These can be categorized as a subsection of family templates because they can apply to different sets of templates. Like for instance, under adaptive, you can create a 2-point adaptive family or a 3-point adaptive family. Structural framing templates works with 2 points, and same thing with arrays. Same thing with line-based families. It is an array, but it works with 2 points. And then you have work planes. Work planes also can be applied to different sets of family templates because it can be either level-based or face based, and so on. All right, so don't take my word for it. I'm just going to show you a practical example. This is which is the basis of today's tutorial. All right, so without further ado, I think we can start. So the first thing is we're going to create a box getter family using a metric structural framing template, beams and braces. And we're just going to remove this geometry, this line, these reference planes. I'm only going to be left with one. So the length of this, I'm going to change it to 30,000 millimeters. Go to the left elevation. We're going to set up our reference planes now, which is one of the first things I always do. And let me just extend this. All right, so I'm going to go to create and say reference plane. I'm going to place one on this side and then another one on that side. Okay, so this one, I'm just going to offset it by 9,000 millimeters, and also this one by 9,000 millimeters. Let's extend this. And let's extend this that side. Okay, so I'm going to select this reference plane. I'm going to copy it to the right by 2,464. And then this one, I'm going to make it 300 millimeters. And then 298. And then 1,472. And then 800. And then 1,000 millimeters. Okay, so I'm going to select all of these, mirror them towards the other side. And then I'm just going to place another one right at the bottom. So this one I'm going to offset by 2,800. And then I'm going to place another one like this. So this one I'm going to make it. So this one, it's going to be 350. And then I think we're going to have another one. Let's place another one like that. So this one I'm going to offset by 250. Perfect. Okay, so from that point, I'm going to create my geometry, go to create extrusion, set my reference plane to the reference plane left, start from the middle point, going to the left by 9,000, down by 250, and then diagonally down towards this point. And then I'm going to take this down at 45 degrees, place it like that to create this protrusion, and then place it like that at 45 again. Go to the left by, go to the right by 1,472. And then from there, I'm going to go down. Let me just, I'm just going to place a random line. And I forgot to place another reference plane. So I'm going to offset this one from the top by 450. And then from there, I'm going to place another diagonal line from that point towards this point. So let's remove this line. From there, I'm going to take this down diagonally towards this point and then towards that point. I'm going to select these, mirror these towards the other side. Let's remove this. Trim and extend, trim and extend. Okay, so I'm going to say pick lines, set my offset to 300 millimeters. Place it like that, place it like this. And then set my offset to 200 millimeters, place it like this. And then another offset at 250, place it like that. Okay, so I'm just gonna say trim and extend, trim and extend, trim and extend. So I'm gonna start from this point. As you can see, it will detect it by aligning it with these temporary blue lines. I'm gonna place my chamfers like this, mirror it towards the other side, and then I'm going to place the other ones from this point towards that point at, let's say, 23.05 degrees. Let's mirror this towards the other side. Trim and extend, 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 trim and extend. Okay, so this is what we have, and I'm going to say finish. And what I'm going to do is, actually, let's go back to our profile again. I'm going to select this line. for our protrusion. I'm just going to copy it. So I'm going to place it. So what I'm going to do is I'm just going to place another line like this. Actually, let's select this line. I'm just going to copy it from that point towards this point. Okay, let's do this. So I'm going to place another protrusion. I'm going to go to the left by, let's say, 600. Diagonally up by 400. And then 400 again. Place it like that. So I'm going to have to make sure these are parallel. So yeah, I think it's fine. Let's see. So yeah, I think it's fine. So I'm going to select these lines, mirror them towards the other side. I'm going to say trim and extend, trim and extend. All right, so I'm going to say finish, apply the material. So this is going to be obviously concrete cast in situ, cast in place, and say okay, go to the reference level. I'm going to select my geometry, drag it towards this reference plane, lock it, drag it towards that reference plane, and then lock it. I'm going to say fine, change this to realistic, and this is what we have. Okay, so yeah, I'm going to change this to shared. I think it's fine like that. And then the next thing to do is our steel struts. So I'm going to go to File, New. Let's cancel File, Family, New, Family. And then I'm going to go with metric generic model and say open. So the first thing I'm going to do is I'm just going to change this. I'm just going to uncheck this box of always vertical. And then I'm going to check this one off work plane based. And then I'm going to make this a shed. All right. So the next thing is I'm going to place one reference planes, two reference planes, one on each side, dimension them, make this equal, select this, create a parameters. So this is going to be our strut length. I'm going to say okay and then lock it. Go to the left elevation, place two reference planes, one on each side. So this one, let's apply a dimension, make this equal, create a parameter. So this is going to be strut diameter. I'm going to say okay and then lock it. Right. So after this, I'm gonna go to create and say extrusion. Place. I'm gonna go with start and radius arc. Place it from that point towards this point. Place it like that, and then align. I'm gonna select my reference plane and then this dot, lock it. Reference plane dot and then lock it. Select this, mirror it down like that, and then I'm just gonna say offset. Pick lines offset. Make it 10 millimeters and then I'm gonna actually let's make it 20 millimeters and then place it like that and then it's gonna automatically lock, say finish, go to the reference level, drag it towards that point, towards that reference plane. So I'm gonna say align and then lock it. So if we go back to the left elevation, I'm gonna change this to 300 and then it's gonna move like this. So I'm going to change the diameter to, let's say, 600, and then it's going to be modified like that. All right, so I'm going to load it into my box getter family, and then go to the left elevation, and I'm going to hover over the face of my box getter, and then press spacebar so that I can change its orientation, and like that. And then I'm just going to place it like this. So essentially, this is what it looks like. So I'm going to go to edit type, change its diameter to 300 and say, okay. I'm going to measure the length from this point, from that face to that face, which is 3220. I'm going to select my strut, change it to 3220 and say, okay. And then I'm just going to manually place it like that. Okay, so obviously I'm gonna have to modify this. So what I'm gonna do is I'm gonna place dimension, which I forgot to do for my steel strut. Let's make this 200. I'm gonna make this equal. Then I'm gonna change this to box girder width. Okay, lock it. This is gonna be box girder depth. And say okay, lock it. So the box girder depth, I'm gonna change it to, let's say, 3.5, and this is how it looks. Or let's make it 4,000. Actually, let's make it 3,750. Yeah, that's fine. So I'm gonna measure the length from this face towards this face, which is 3892. I'm gonna select this 3892 and say okay. And then I'm just gonna manually adjust it like that. Okay, so I'm gonna select it, go to the back elevation, and I'm just gonna adjust it the side, just place it, nudge it like that. All right, so I'm gonna press AR on my keyboard for array. Make sure you set your constraints to last. I'm gonna change the number to 15, and then I'm gonna press this point, drag this, place it this side, and then it's gonna place 15 of them. Go to the 3D view, and this is how it looks. Okay, so what I'm gonna do is I'm gonna select all of these, ungroup them, go to the left elevation, mirror them towards the other side. And this is how it looks. They look. So I'm gonna select all of these. And what I'm gonna do is I'm just gonna go to Edit Family, go to Properties, and then I'm just gonna change this, go to Edit, change these parameters to Instance so that we can associate them. I'm gonna load it back into my box girder family, override them, select all of these. And what I'm gonna do is I'm just gonna say, as you can see, the dimensions now have appeared because we made them instance, they appeared on this side. So I'm gonna go to uh, this box, which is this button, which is associate family parameters. I'm gonna select it and then create parameter. So I'm gonna name it strut diameter and say okay. And then I'm gonna say okay to associate it. And then after you do that, you're gonna go to your properties, and then it's gonna appear under your properties for the host family. Okay, so we're gonna associate. You're gonna select one. Let's say select all instances, associate. We're gonna create this one, which is strut length. I'm going to say okay, and then okay. And then it's going to appear under your properties of the host family. So I'm going to change this to 300, apply, and then okay. All right, so this is how it looks. All right, so to test this, you're going to go to File, New, and say Project. I'm going to choose a construction template as my basis, and then go back to my family. Remember, this behaves like a beam, so you're going to load it in and it works with 2 points. So you're going to select, place it like a beam, which is 2 points, and drag it. But I'm going to make it 30,000 millimeters in length. Go to the 3D view, and this is how it looks. So if I change this to realistic, this is what we have. So when you hover over this, press tab, you can select the struts individually. It allows you to do that because why? We made this a shared parameter, which means the quantities are very much separate. So if you select all of this, um, you can go to edit type, and then you can see your parameters there. You have your strut diameter, strut length, box girder depth, box girder width. All right. And then when you generate your schedules, right click, new material takeoff. I'm going to say multi-category, and then type in category, load it in, type, load it in, family, load it in, area, load it in, volume, load it in, and then go to your sorting and grouping. sort by category, then by type, add your blank lines, footers, change this to totals, grand totals, changes to total, itemize every instance and say okay. And okay, it didn't separate, so let's do this. Edit. Let's say edit strut. We made this a shared, it's fine. Let's go to structural framing. Edit category type sort. Okay, category type and then family. Okay, let's create a new schedule. New schedule, multi-category, and then category, type, family, and I'm just gonna go to sorting and grouping, sort by category, then by type, and then add your blank lines, footers, totals only, grand totals, make this totals and say okay. There it is. So it now separated your families, and yeah, this is how it looks. So I don't know why it doesn't do that on our takeoffs. It's fine. So you can just use a multi-category schedule, so it's gonna separate them like this. So let's go to sorting and grouping. We added our totals? Yeah, I think it's fine. The structural framing is basically that box getter that we have created, and these generic models are basically our steel struts. So yeah, that's it. Thank you guys for watching, and I hope you learned something on this on the three stages of building a Revit family. It involves modeling, nesting, and also the placement. Please like, subscribe, and share. And yeah, I'll see you on the next tutorial. Peace.